It's an absolutely beautiful day, and very few clouds in the skies, and as usual the colony of rooks nesting nearby seem to agree, as even more noisier than usual this morning. The sun's still fairly low, so I'm going to get everything set up and ready to do some, well, hopefully do some solar imaging today. I'm Dr. Ray, and welcome to AstroGadge. Hi folks, and welcome back to the channel. Well, it's end of May here, 56 degrees north. It doesn't get dark really, it just goes to twilight and then gets light again. So it's completely out of the question doing any deep space object astrophotography. So let's go and try some solar observing. It's not something I'm terribly experienced with. I'm finding my way with this, so any of you guys got any comments that what I'm doing is rubbish, or suggestions, tips and tricks, please let me know in the comments, and you know, that way I get to learn stuff. As I said, I'm going to try some solar imaging today, but what I'm going to do is, because I'm going to be using the Daystar Quark Hydrogen Alpha eyepiece. It's not really an eyepiece, it's a filter, but never mind. I've used it in the past, not to any huge, great sort of success, so I thought, you know, we've got so much time on our hands here, why not give it a try? The thing is, we'll be talking a bit about that in a minute. Because it contains a Barlow and I'm using a fairly short focal length refractor with a limited objective size, I'm not going to get the whole disc in, so I thought I'd try something a bit difficult. Probably a bit difficult for my skill level at the moment. So what I'm going to do is I'm going to try and make a mosaic image of the sun. So without any further ado, let's go and have a look at the equipment rig I'll be using, the setup I'll be using, and have a look at the Daystar Quark itself. So this is the imaging equipment we're going to be using today. We have the Williams Optic ZS61 coupled to the Daystar Quark. It's the prominence version, and for the camera we have the ASI 178 monochrome camera, high frame rate. This is all connected to fire capture for data acquisition. I've also fitted it with a solar finder, which is actually really invaluable. It really is helpful in getting the sun right in the centre of the field of view. You'll notice here that there's some counterweights I've placed on the telescope, and that's quite simply because I'm far too lazy to actually change the mount, because this mount's permanently set up. It's the EQ8R Pro, and this telescope's far too light for it to get balanced, so I've had to compensate using counterweights. So yes, I could have used another mount, but it would have meant trying to get the thing polar aligned during the day, so I'm just too lazy to be bothered with that. So it's on the permanently set up mount. So once we're ready to go, we'll hopefully get some images. I'm going to talk a bit more in depth about the Daystar Quark shortly. So this is the Daystar Quark Hydrogen Alpha filter. It's sometimes referred to as a solar eyepiece. It's not, it's actually just a filter that basically contains an etalon like you would get in a dedicated solar observation telescope. But the beauty of this unit is it will fit onto pretty much any refractor telescope that you have, so there's no need to buy a dedicated solar scope. You can fit onto your existing equipment, particularly if the refractor you're using is under I think it's under 100 millimeters in diameter. It contains a 4.2 times Barlow integrated into the system, and apparently the reason for that is the unit actually will only work as if the light from the telescope is parallel to the etalon. Now, like a lot of what the etalon is in a unit like this, and indeed in solar scopes, it's simply a device, and it's an interferometry device which fine-tunes a very narrow band of wavelength. In this case it's about 656 nanometers, the hydrogen alpha line of the sun. And some etalons are pressure tuned. This one isn't. This one is tuned by heating the element. And to do this with this unit, it's plugged into a 5 amp 1.5 amp.
What's the matter with you? Are you stupid or what?
Supply. In this case I'm just using a battery, and you'll notice first of all that the light comes on, a little yellow light. Once that light turns to green, the etalon is up to temperature and is ready to go. Now this button here, or this dial, you move it one way, it gives plus 0.5 angstroms adjustment to the etalon, and you turn it the other way, it gives a minus 0.5 angstrom adjustment, and there are 0.1 increments either side of that. And in my case here, I found out where the sweet spot is. So the idea is that you can fine-tune the etalon or the device to your specific setup. As I say, I've marked where my sweet spot is here on the thing. So as I said, it has a 4.2 times Barlow incorporated, which has particular issues which we'll talk about in a minute. In my case, I've been using it with the Williams optic Zenith Star 61, which is a focal ratio of 5.8, I believe. So in that respect, it's that actually is a fairly good fit for this device. So the downside, obviously, with something like the ZS61 is its objective's only 61 millimeters, so it gives you a fairly narrow field of view, which is one of the reasons I'm going to attempt a Mosaic in the session. There's no need for an energy rejection filter in this unit. It's already built in, so once it's plugged into the scope, it's pretty much ready to go, ready to use. It comes in two versions. This is the chromosphere version. That means it's optimized to visualize or image the chromosphere of the sun, and it also comes in a prominence version, which means it's optimized to view or image the prominences. Despite this being the chromosphere version, I've tried it out before, and you can pick up prominences absolutely no problem at all. So whilst it's strictly speaking not optimized for prominences, it does a good job in them anyway. The advantage to this unit is quite simply you don't have to have a dedicated solar scope. You can essentially plug this into any suitable refractor that you have. If you are going over 100 millimeter diameter objective, then they recommend you use an energy rejection filter. and it's good practice even if you're under that to use an infrared cut filter, infrared ultraviolet cut filter in the light path as well. So it has a 2-inch barrel here and a 1.1 1.25 inch barrel as well, so adapter. So it's pretty much compliant with any telescope. Now, one of the problems this thing does have is, particularly with certain cameras, depending on the distance between the sensor and the glass or the sensor cover, the light, the monochromatic light produced by the etalon can end up producing what's called Newton's rings. It's basically an interference pattern which manifests itself as sort of banding across your field of view or your image. Now, you can mitigate that in post-processing, but I always think it's best to, if you can, mitigate that before you get to that stage. It just makes life generally easier. And I'm just going to unplug this for a second. And fortunately for this unit, there is a hardware solution. It's this thing here. Now, normally in astrophotography, as you know, one of the things we hate in any optical chain is tilt. But in this case, counterintuitively, in order to get rid of that problem, you need to, if you're not going to try it in post-processing, is use this thing here, which is basically a plate to produce tilt in the system. And it basically adjusts these screws, and you don't need a huge amount of tilt, just ever so slightly until the banding disappears. And it does it very well. I mean, the banding, the actual adjustment is tiny, but it's sufficient to prevent this interference pattern that's produced as a consequence of, well, as I understand it, the design of your camera and also the configuration of your telescope, as I understand it. So this is a unit that fits on top of the filter. So once that's in place, obviously, I have here the ASI 178 monochrome camera. Now, one of the things they do say is if you're using the tilt plate, then the back focus between here and the sensor and the camera has to be 55mm, so I've introduced some spacer systems here. So, as I said, apparently not all cameras suffer from this. As I say, it depends on the system they have for the between the actual sensor and the cover plate. I think the distance in that is not the same in every camera maker model. Certainly in this camera, the ASI 178 monochrome, it does produce, without the tilt mechanism, it does produce Newton's rings. Incidentally, I've tried it on the 385 color, one-shot color camera, and again I was getting interference patterns on it, and again this unit's mitigated all that. So I ended up with 24 different video sequences, and I manually moved the field of view each time, being careful to leave sufficient overlap between each sequence, so that when I processed each video sequence into a still, there was sufficient detail in the overlap for the Mosaic stitching software to get hold of and to actually do its job. Once I got the video sequences, I processed them in AutoStacker 2, just as you would lunar or planetary imaging, using the appropriate settings So once I'd processed the video captures, processed them in AutoStacker, I ended up with 24 TIFF images. Now I've not sharpened them at this stage. Maybe it was the wrong thing to do, but here's my logic. Just bear with me. I was going to wait until I got the full Mosaic before I did any sharpening, and the logic behind that was that way the processing of the final image would have been a lot more consistent. That's my thinking. That's my thinking, folks. Please let me know if there's a better way of doing this or what you did. So up here, we've got the 24 images, which are now ready, or in my opinion, ready to be stitched together. So now we're ready to try and stitch all these images together, hopefully seamlessly. And you can do this in various pieces of software like Photoshop or whatever. But what I'm using, and I've used it before in the past for other things, and it's a fantastic piece of software, is Microsoft Image Composite Editor, otherwise known as ICE. Now, I've been told that it was no longer supported by Microsoft. It wasn't available from the store. But fortunately, it's still available from reputable download sites. And this is what I've done. I've managed to get a copy of it. Brilliant, absolutely brilliant, because I love this software. Although, as I say, there are other ones that do the same job. But this is free, and it does an excellent job. Well, it has done in the past. So, delighted to say I've got a copy of it. And it's simplistic to use, which suits me right down to the ground. So how you use this is what I love about it. It's pretty straightforward, and we'll go through it right now. Now, I'm going to put a link for this in the description of the video, but I'm also going to, it's also here at the bottom of the screen. I'll leave it up for a couple of seconds as I ramble on. So to use this, straightforward, what we do is we simply go when you make a new panorama from images, so just simply click on that, and then what we're going to do is simply select the various components of the mosaic. You know, the 24 images I've ended up with after stacking the 24 different video captures. And we're going to open that, and here we go, and as you can see, it's loaded them. Fantastically intuitive. Tell it to stitch them together, and hopefully it will do that. So it seems to have done a reasonable job. Let's have a look. Yes, it has. Wow, that looks very, very good. That looks very good. Well, to my eye anyway. As I say, I don't have a huge experience in this sort of thing, but first glance it looks very good. You can simply then have the option to crop, so I'm going to press crop. You'll notice that there are gaps in the image where the sub-images haven't quite been large enough to encompass the sky beyond the disk of the sun. All we need to do now is to save it to disk on the computer. So press export, and there we have it. So here we have the complete image in Registacks, and we're in the wavelet section where we're going to start playing about with the sliders, different wavelets, fine to coarse, adjusting the noise levels as we go, and we should end up with a sharpened image of our composite. For the next part of the processing, I'm going to use a program called INPPG. It's a free piece of software, and hands up, I haven't really got to grips with this yet. I can do lots and lots of different things, but I haven't got to grips with all that yet. But what I have used in the past is this thing here called the tone curve.
And this is a fantastic tool. It really does allow you to bring out lots of detail that's otherwise obscured. For example, in this image, you probably can't see it too well on YouTube, but there's a hint of prominence activity here and possibly around the different areas of the sun. And what you find is if you play about with this, it basically adjusts the tonal range. So you can see as I increase this, the detail's starting to come out here. There's definitely a prominence of some sort over on this end. So I found it's really just a question of playing with this until you get a pleasing result. And yeah, there we go. So you can see straight away as it was brought out some prominence activity around the limb, right around various areas. I really need to play with this and get to know it a lot more, because I'm sure I'm just, I'm not sure, I know I am just scratching the surface with it. And again, you know, please, if you've got any pointers to using this and got this all wrong, then let me know. So once we've got the detail, we've eked out all the detail we can using the tone curve, then obviously we'll save it and we'll do some further processing to just try and make the image pop a bit. And what I've done to actually fill in the gap, so to speak, in the sky, I've simply just used a cone stamp of the surrounding sky and then just filled in the white gaps. Alright, so to add colour to this and really try and make the image pop, what I've done, you can go to, well, first of all, go to the mode. And remember, this is a black and white image, so we'll tell it to make this a colour image. So it's just simply image mode, and then click on the RGB colour. And once we've done that, go to layer, new adjustment layer, hue saturation, and then it will come up with this little thing here, which we press OK, and again it will produce this thing here, and we push colorize, and lo and behold, there's colour added to. Now you're probably thinking, yeah, well, why don't you use a one-shot colour camera? Well, you could, yeah, and you'd probably get a very good image going through this process, but as I understand it, it's back to the whole debate about colour or one-shot colour camera. But for the sun, they certainly do recommend monochrome imaging. Anyway, we've added colour to it, and then it's simply a question of playing this thing that I kind of like the orange kind of vibe on it. I don't want to make it too yellowy green, and then of course all you have to do is play about with the saturation, bring the hue back a little bit. Again, if I'm getting this completely wrong or I'm missing out steps that you feel could improve this, then please let me know and give us some insight or tips that may help.
Well, folks, that went not too badly, dare I say it. I've probably made lots of mistakes, done lots of things maybe I shouldn't. I know there's a lot of you out there that have got a lot more experience in solar imaging than I have, so you know, as I said earlier, please let me know in the comments if I'm getting everything wrong, or suggestions of how I could be improving things. But you know what, I'm actually quite pleased with the results of this. I know it's not a perfect result, but you know, for a first attempt, particularly with the Mosaic, I'm actually very pleased with the results. Not perfect, but I'm pleased with them. So I'm going to put the completed image up at the end of the credits. Meantime, just to say thanks so much for watching the channel. If you're new to the channel, please consider subscribing. Please consider giving a thumbs up if you enjoyed it. Subscribing doesn't cost you anything. It simply means you get a heads up whenever I post any content. So meantime, thanks again. Thanks for watching, and remember, keep watching the skies.
Watch the skies everywhere. Keep looking. Keep watching the skies.